We just touched briefly on fuzz testing in the last clip, and inevitably the SQL Injector browser plugin of Firefox was doing a very rudimentary version of that. Let's take a moment though and define what I'm talking about with fuzz testing. And really it's all about using automation to take, as the definition here says, invalid, unexpected or random data and throw it into the inputs of a system. So in the case we just saw, that was SQL injection style attacks thrown into form fields. Let's take just a moment to have a look at some of the typical payloads that you might use when fuzz testing for SQL injection risks. What you're looking at here comes from the FuzzDB project over on Google Code, and inevitably a lot of this should now be familiar to you. So you'll see a bunch of tautologies, everything from the very classic 1 equals 1 through to other equivalencies using letters or less common patterns. So think about the previous module on evasion techniques. A good robust set of fuzz testing logic is going to include all sorts of values that may actually be the ones that slip through SQL injection defenses. So beyond just the tautologies, we're also seeing a bunch of union style attacks. We can see hex encoded attacks. And of course we can see some SQL injection keywords and system commands. And in total we're looking at 143 different possible strings here. It's certainly not exhaustive, but that's a reasonable range for us to use in this next automation example. So I've got a copy of all these on the clipboard. And what I want to do now is jump over and show you Burp Suite. Just before I do that though, I want to jump back to the vulnerable website and make a quick request. Okay, so here we are back on the vulnerable website. I'm going to scroll down to the cylinder layouts where we've spent so much of our time testing SQL injection in this course. Now here's what I'm going to do. I'm going to hit the link to the 4 V12 cylinder layouts, and what you'll notice is that the website is just sitting here, not responding. Now there's nothing wrong with the site, but what I've done is set up my browser to proxy through Burp, and what that means is that Burp has intercepted this request and it's now waiting for me to take some action. So let me now jump into Burp. So this is Burp, and I'm using the free edition here. There is a commercial edition as well. And the thing about Burp is it makes it very easy to proxy your browser traffic, intercept the request, manipulate it, and then fuzz test the resource that that request was being sent to. Now we can see the proxy tab up the top here has gone orange. So let's jump into that. And then here we can see the request that we just issued from the browser. So in fact, you can see here that it's a GET request. And of course, it's going to cars by cylinders with the query string parameter of cylinders equals V12. Now we've also got all the other request headers here. And what Burp has done is highlighted every section here which it thinks might be suitable for some fuzz testing. So effectively, it's all the input parameters, so V12 on the cylinders value, and it's all the cookie values as well. Now here's what I'm going to do. I'm going to jump over to Action, and I'm going to send to Intruder. Now when we do that, the Intruder tab goes orange. I'm going to jump over to Intruder. We can see the host represented here and the fact that we're talking to it over port 80. I'm going to go to Positions, and what we see now is every one of those pieces of untrusted data being highlighted in orange. So remember we defined untrusted user data earlier on in the course, and it's basically anything that an attacker can manipulate and submit back to the site. Now that's exactly what we're going to do here. But what I want to do first is clear all these other payload markers, because the only thing I actually want to test is the cylinders. So let's clear that. I'm going to select V12, and then I'm going to add it. So now we've only got the one marker, it's just V12. Now I'm going to jump over to the Payloads tab because we need to define what it is that we're going to fuzz test that parameter with. Now I've got all of those 143 fuzz testing SQL injection patterns we saw just before on my clipboard. So I'm just going to paste those in here to the payload. And what I'm going to do now is jump up here to Intruder and start the attack. I'm getting a little warning here about the free version. It is going to be time throttled, as well as having some other functionality disabled. So clearly there's a bit of an upsell here to the professional version. But this is fine for now. I'm going to say OK to that. And then I'm going to maximize this window here. Now we'll see one request here with a comment of baseline request. So this is just a request exactly as I issued it from the browser. We can see that it has an HTTP 200 status and it's got a length of about 5700 bytes. We can also see a number of other requests now appearing, and effectively each one of these requests is a test for the pattern that we saw before on the fuzz test slide. And we can see that these tests are now returning sometimes different status codes and sometimes different lengths. Down the bottom left-hand corner of the page, we can see the progress. So we can see the full 143 tests there still ongoing. Here's what I want to do though. I want to have a look at just a couple of specific requests, and in particular at the responses. So I'm just going to pause this attack for now because I'm just going to use the first few results to demonstrate what we've actually gotten out of this process. And I'm going to start by looking at this first request here, at least the first one after the baseline request. Now when I select this request, we can see some tabs below, and it's defaulted to the request and to the raw request. And this is basically just what we saw before, the only difference being that the cylinders parameter has now got that SQL injection attack in it. So this is the pattern that we are fuzzing in this request. Now if we go and take a look at the params tab, we'll see that represented a little bit more clearly. So all the cookies are the cookies from before, but there's this URL value which is our SQL injection test. What I really want to look at now though is the response, because I'm a little bit interested as to why this response is only just under 4K. So that's actually quite a bit smaller than our baseline request. And really this is the whole point of fuzz testing, trying to see which requests are causing the page to behave differently. So what I mean by differently is things like a status that isn't 200 or a response length that's very different to the original one. So the response defaults to the raw response, but for the sake of legibility, let's jump over to the render response because this is going to show us what the actual web page looks like. And if we scroll down a little bit here, we'll actually see that this is the entire page. There's no CSS or nice styling, but we can clearly see our attack pattern repeated at the top of the page. So remember, this is where you'd normally see something like V12 engine layouts, and then that's it. So basically what's happened here is that there hasn't been a successful SQL injection attack. The underlying database query has returned no results, and the page is just reflecting the input. I'm a little bit more interested in this second request though, because we can see that that has an HTTP 500 response and quite a large response body. And if I click on this, we can see that the render is now actually reporting a server error. So this is effectively confirmed error-based SQL injection, in part because we can see it's an internal exception, and in part because the exception details do actually disclose that it is a SQL exception type. So this result here says to me, this is something that we want to investigate further. So that's a good fuzz test result. Let's pick one more example, because down here on request number 6, we're getting an HTTP 200, but we're also getting a response size that's sort of partway between our baseline request and the exception we just saw on the 500 response. Let's have a look at this one. Now I'm going to slowly scroll through these results, and what we're actually seeing here is the Agera R, the GTR, the Wayera, La Ferrari, and in fact if we keep going, we'll see we've got all 10 results. So what this is telling us is that the SQL injection payload, which we can clearly see is a tautology, is returning all 10 vehicles, not just the 4 V12s. So this is confirmation that it has found a valid SQL injection attack. Now of course, you still need to go and do something with this. This isn't actually getting data out of the system. It's enough to confirm there's a risk, but it's always nice when you can actually demonstrate the exfiltration of data. So to do that, let's move on and take a look at Havage.